Let's take a look at the process of a limit graphically. So I'm hoping that this demonstration on Desmos will help illustrate what's going on. Here in red, I have graphed the function y equals the square root of x, and I am going to follow the limit as x tends towards the coordinate 4. So I have been saying in my past lectures about we can trace along the path that the graph is making for us, or the curve that the graph is making for us. I'll turn on these equations. These are just rigged up to show me exactly what's going on. So this point here is going to be a point on my graph. The vertical green line is telling me the x-coordinate. The horizontal green line is telling me the y-coordinate. And by moving this slider down here, I can move the x-coordinate to the right and to the left. So watch the vertical line as I move the x-coordinate closer and closer and closer to 4, and then I get to 4 coming in from the right, or I can overshoot, I can come in from the left instead, right? So I have to be concerned about a right-sided limit and a left-sided limit. But I can also be focused on that horizontal line, which is telling me the y-coordinate. So as my x comes in from the right, my y-coordinate is approaching 2, like this. If I come in from the left instead, my x-coordinate is tending to 4 from the left, and the y-coordinate approaches 2 again. So it appears that the limit of the square root of x function as x tends to 4 is going to equal 2. And that will be a two-sided limit. Now, I've talked before about deviations, right? So I have this idea that the function should be getting closer and closer and closer to the y value of 2. So at some point, we should be within this red region. So I start outside of the red region, and I come in and closer and closer and closer, and now my y-coordinate is what I will call close to the y-coordinate of 2. So I'm using d here, or your textbook uses delta here, to control the closeness that we want. So I can shrink that a bit. Now I'm looking at a smaller window. These x's out here are too far away. These x's over here to the left are too far away. But here in the sweet spot, I can say as long as x is close enough to the coordinate 4, y is going to be close enough to the coordinate 2. And I can shrink my window a little bit more. I might have to zoom in to see it better, but I can move my x-coordinate in a little bit more and stay inside of that window. So just like I've highlighted on the y-axis how close I want to be, I can drop in vertical lines here and check on the x-axis how close I need the x variable to be. So let me turn on this highlight. The blue highlight is now telling me exactly how close to the coordinate 4 my x variable needs to be in order to make the y variable as close to the coordinate 2 as I want it to be. So the y coordinate is my target. The x coordinate is what I actually get to manipulate, though. So over here, oh, too small, I'm too far away, I'm outside of that red window that I want. if I want to be inside, then my x has to be in this blue region. So if we want the y coordinate to be within epsilon of the coordinate 2, then there's going to be some different width here that x has to satisfy. So we would use epsilon for the vertical distance and delta for that horizontal distance. I've gone ahead and I've rigged up this formula sheet so that you can actually make the window really big, you can make the window really small, and Desmos is doing all of the calculating for how wide this interval should be. So again, the idea of limits is asking, can we guarantee that we will always be within, say, 0.05 of the correct y coordinate? Well, there is my window for distance equals 0.05 or epsilon equals 0.05. And I have projected down onto the x-axis to say that if you want to be within 0.05 of the limit of the coordinate 2, then the x value has to be close enough to the coordinate 4. And what is close enough here? Well, if this is 3.5, looks like this is 3.5, 3.6, 3.7, 3.8, 3.94. Yep. So the smallest x can be here would be 3.8. The largest x could be here is 4.2, looks like. So I would say that if you want to be within 0.5 of the correct y coordinate, then x has to be within 0.2 of the correct, of that stopping x value. So I'm going to adjust my slider here. So now that's only as far as my x can go. See, it's stopping on the left, it's stopping on the right. As long as x stays inside that blue window, which is where I can control the x variable to be, my y variable stays inside of the red window, which is where I want my y variable to be.